So essentially, we can have infinitely many normal curves corresponding to different means and standard deviations, right? The mean is going to determine where the middle of the curve is, and it can fall anywhere along this x-axis, right? So a different mean will just be the same shape, but move to the left or right, right? It's just going to shift it back and forth along that x-axis. And the standard deviation is going to tell us how distributed the data is, whether it's, closely clustered around the mean or whether it's more distributed. All right. So essentially these curves all have the same shape relatively. It's just that they're shifted back and forth along the x-axis, or the values are, scaled up and down or distributed, stretched in the horizontal direction according to the mean, or sorry, according to the standard deviation. So we're going to introduce now the standard normal distribution, which allows us to take, it's just a standardized normal distribution with a mean at 0 and a standard deviation of 1, and then we can use it to create any normal distribution we want. So let me write that down. All right, so the standard normal distribution has a mean of 0 and a standard deviation of 1, and we can use it to create any normal distribution. Okay. The other thing that's important is that we use the random variable z. Random variable z is considered the standard normal variable. Okay. So let me take a look. Let's see what's coming at this. So we have something called the z-score. All right. So we're going to take our random variable and we're going to scale it to a z-score. Okay. And the z-score is essentially the number of standard deviations that a data value has from its mean. So z-score is the number of standard deviations a data value is from the mean. So if you look back at example 1, we had the scores that were clustered around a mean of 450, and 425 was one standard deviation below the mean. So we would consider its z-score to be a -1. We had a 475. 475 was one standard deviation above the mean, so its z-score would be a -1. Okay, so in general, we define the z-score. We can calculate the z-score just by taking that data point minus the mean and then dividing by the standard deviation. That'll give us our z-score. So once we have a z-score, then we can use the normal standard distribution function to look up the probabilities associated with that z-score. Okay, so now the normal standard distribution function is given as a table. All right, let me show you what that looks like. So here I have this normal standard distribution function as a table. So let's see how we use this. I think it'll make more sense when we go through an example, but let me just kind of give you a preview of what it looks like. Essentially, all these numbers are probabilities. They're the probability that the z-score is less than some value. Okay, so if we know the z-score, we can use the table to look up the probability of the z-score being less than that value. Now you can see we have, there's a lot here. All right, here's our z-score right here. Right, this is the first 2 digits of the z-score right here, all along this this column here. So those are the z-scores. We have, they're starting here at -3.4, and then going by tenths all the way to a +3.4. Okay, now those are the first 2 digits. The second decimal place or the third digit is given across the column here. Okay, So for example, if we want to look up the probability of a z-score being less than, let's say, negative 0.5, let's go back up here where I can actually see. I can see the whole column. Okay, so let's say negative 2.08. All right, so I've got negative 2.0, and then to get negative 2.08, I'm going to go across the column to where I have the 0.8. All right, so I'm going to come down, and so this will be the value. This is the probability that a z-score is less than negative 2.08. All right. So I have the ones place and the tenths place given in this first column, and then the hundredths place is across the top here. So we have to kind of go, look it up by the digits of the z-score. Okay, so all right, so let's go back to our example here, and let's see how we do this. Let's see, I need to go here. All right, so let's look at example 2. We're asked, the first part A is just asking us to, well, we want to know what's the probability that a z-score is less than 1.24. Okay, now the problem is asking us to let z be the normal variable and sketch the appropriate region. So we're looking for, let me go back to my pen here. And so we're looking for a z-score less than 1.24. So let's say that's about here. I'm just going to kind of guess. I know that this is 0, right? So this is a z of 0. And so 1.24, I'm going to just guess that it's about here. Let me make that a little nicer. So let's just say this is 1.24. Okay, and we want to know what's the probability that the z is less than 1.24. So we're essentially looking for this area, right? So if we want to sketch the area, that's what it looks like. We're looking for that area. All right, now we can just look that up in the table. So let me go to the table here. And it was 1.24, right? So we're going to use our table. And this is going to be a little tricky because it's just not easy to do in a video like this, but I'll do my best. So I'm going to go down to 1.2. All right, so here's 1.2. Let me pick up my highlighter. So here's 1.2, and I want 1.24. Now let me scroll up so I can see 1.24. So I need to come across 1.2 and then go over to the 0.04. So this is the hundredths place here. So I come down, and this is the value that I'm interested in right there, 0.8925. All right, and that's my answer, essentially. So the answer here is that the probability that z is less than 1.24 is just that value that I just looked up, 0.8925. So it's saying that that the probability of the z-score being less than 1.24 is 89.25%. So 89.25% of the values are less than 1.24. Okay, and we just do that by looking this up on the table. Look it up. Look it up in the table. All right. Now, that was pretty straightforward because our table is set up to give us values that are less than some z-score. But oftentimes we want to know the probability of something being greater than some z-score. Okay, so that's what this next example is showing us. We're looking for the probability that the z-score is greater than 0.5. So let's sketch in what we want here. So let's say 0.5 is about here, right? I know again that the mean is 0, so 0.5 is going to be above the mean because it's positive. And now though we're looking for this area. Okay, 0.5 is. Now there's a couple different ways we can do this. One way that we can do this is by using the symmetry of the table. So this is not what we want. But I know that this area right here the area below a negative 0.5 is equal to the area above 0.5 because of the symmetry. So one way that I can do this problem is to, so I'm looking for the probability that z is greater than 0.5, but using the symmetry, that is the same as the probability that z is less than a negative 0.5. Okay, so then I can just look that up in the table. So if I go to my table here, let's go back and forth here. So 0.5 is right here, but it's not what I want, right? That would not give me the right answer. What I want is a negative 0.5, right? Because this would give me the probability. If I look this one up, this gives me the probability that it's less than 0.5, but I want to know what's the probability of it being greater than 0.5. So I'm just going to go to use the symmetry, and I'm going to look up negative 0.5, and I get 0.3085, right? So that's my answer. That's one way I can get my answer. So let's go back here to this, and let me write that down. So this is the number that I just found was 0.3085 just by looking it up on the table. But I'm looking up the opposite, right? I'm just using the symmetry of the table, and so I'm going to look up the probability that it's less than negative 0.5 in order to find the probability of the z being greater than 0.5. Okay, now there's another way I could do this, and I could just use the fact that the total area under the curve is 1, right? So another way I could do this is that the probability that z is greater than 0.5 is equal to 1 minus the probability that the z is less than 0.5. So then I can look up 0.5, but I just got to keep in mind that essentially it's a complementary probability. It's going to be 1 minus the value that I look up. So if I look up positive 0.5, right, which I kind of did down here, right, I got 0.6915. Okay, so that's just right here. Oops, right here. And so now if I go back to the problem I'm working on, so I looked up, I found that the probability that z is less than a positive 0.5 was 0.6915. Subtract that from 1, and I get the same thing. Oops, 0.3085. All right, so that's just another way to do it. Whichever way you prefer. You can either use the symmetry or use the fact that the area under the entire curve is 1. And just use the complement, right? Because it's either got to be greater than 0.5 or it's got to be less than 0.5. So we can use the complementary probability. All right, now there's a couple more variations of these types of problems which you need to know how to do. And that's when we're looking for the probability that a z-score falls within a certain range. So I've got a couple of examples here of that type. And so let's see, how are we going to do this? Let me first of all sketch it, because sometimes sketching it is kind of the key to really grasping the concept. All right, so these are both positive values. They're both going to be above 0. So remember the z, or the mean is 0 for the standard normal distribution. So 0.24 might be about here, 0.24, and say 1.48 might be about here, 1.48. I'm just guessing where they are. They don't have to be very accurate. But essentially what I'm trying to find is this area right here. Now again, the table that I'm given only tells me the probability that a z-score is less than a certain amount. But now I want the probability that it's between these values. So if I look up the probability of a z being less than 1.48, let's say, what I'm going to end up with is this whole area. I'm going to try to highlight it. What I will get is this, right? That will be the probability that z is less than 1.48, right? So if I look that up, so rather than going back and forth between the tables, I'm just going to write it down. What I found was that it's 0.9306. Okay, just looking it up. And now I can also find the probability that z is less than 0.24, right? Now that is this area. Let me see, I'll get a different highlighter. That's this area here, right? That's this area right there, okay? And I looked that up and I found that that is 0.5948. So you can see if I take the yellow area and I subtract off the area that I highlighted second, which was actually pink, but it looks kind of orange against the yellow. If I subtract off that pink area, what I'm left with is the area that I want, the area between 0.24 and 1.48. Okay, so the way I'm going to do this is I'm going to find it by, so I'm looking for the probability of that the z is between, whoops, Control Z, is between 0.24 and 1.48. Okay, so I'm going to take 0.9306 and subtract off the area that I don't want, which is the area less than 0.24, which was 0.5948. Okay, so I'm just subtracting that off, and what I'm left with is what I want, which is 0.3358. All right, so these can be a little tricky. Takes a little practice. Let's look at another one, and then I have a whole another set for you to try on your own. Now you can go ahead and pause the video and try this one on your own. But let's go through this one. So I'm looking for the probability between negative 1.65. So I'm just going to say, okay, that's somewhere over here. It's less than 0. So 1.65. And then and between that and 2.02. So let's say that's about here. All right, so I'm looking for this area. So the probability is going to be the difference. I'm going to take the probability that z is less than 2.02, and I'm going to subtract the probability that z is less than minus 1.65. Okay, that's how I'm going to get the probability that I want. So we have to look those up in the table. So the probability that z is less than 2.02 is 0.9783. And then I want to subtract off the probability that it's less than negative 1.65, which is 0.0495. Okay, I just got that by going to the table. All right, then I just take the difference of those two values. So I get 0.9288 when I subtract. All right, so that takes care of this example. And the next example is one for you to try. And because I think it's a good idea to give this a try while it's still fresh in your brain. Give it a try, and then if you have trouble, just watch the next video. You know, you don't have to watch the video for example 3 if it all makes sense to you. Or you can watch, you know, skim through it to get the answers to check yourself. So I will meet you in the next video.